So now we're going to talk about limacons. So these have the same form as our cardioids, but the A-B relationship is different. So it's right there. And so we're looking for when A over B is between 1 and 2. Okay. With a cardioid, A over B equaled 1. All right, so we're looking at this equation and we're matching the form. And it looks like it matches to this one here. So you have your A minus B sine theta. That's what we're looking for. And then if you notice what A over B is here, it's A over B is 4 over 3, and that's between 1 and 2. So it's going to be this one. It's going to look something like that. All right, so the next thing to do is to check for symmetry. So we can put in negative r and negative theta. And because sine is a odd function, we're going to get negative r equals 4 plus 3 sine theta. So it's going to say no, it's not symmetric with respect to theta equals pi over 2. And then you can do the other ones. R equals 4, it would be plus 3 sine theta. Okay, that's going to be a no. And that would be symmetric with respect to the pole. So it's not going to be symmetric with the pole. I'm sorry, the polar axis. And then the other one would say negative r equals 4 minus 3 sine theta. And those are not going to be the same as the original. So no, it's not symmetric about the pole. Now, so you might be saying, oh, there's no symmetry. But look at this graph. It obviously looks symmetric about the theta equals pi over 2. Like if I draw a line here, it looks like I could fold that and the points would match up. So our tests for symmetry are not foolproof. Like if you get a no, it's not a guarantee it won't be symmetric. Okay, if you get a yes, it's going to be symmetric, but a no doesn't mean that it couldn't still be symmetric. Okay, so that's probably a little confusing. Now we need to find zeros, right? Okay, so let's think about setting our function here that we have, setting that to 0. So step 3, try to find a 0 or zeros. So I'm going to have 0 equals 4 minus 3 sine theta. So if I do a little bit of algebra, I'm going to get 4 over 3 equals sine theta. That's a problem, right? Because sine only has a range of negative 1 to 1. So this is not possible. Okay, no, this isn't going to work. So you can do inverse sine, but you're going to get like a domain error on your calculator. But what that means is it does not, our graph does not go through the pole. It doesn't mean it's not going to cross our old x-axis. It just means it's not going to go through the pole. Okay? And if you look at all these graphs here, none of them go through the pole. Okay. Now, what about a maximum? So, could we get a maximum situation? Well, we know that sine theta, the maximum output is 1. So r equals 4 minus 3 sine, and that occurs at pi over 2. So we're going to get, let's see, r equals 4 minus 3, which is 1. Now I want to make like a table of values here. So r and theta, when I have r being 1, that occurs at pi over 2. And then I can graph that point. Okay? Now, to find other points, I could do, other special angles. So let's go ahead and do a few. Let's do pi over 6. And you can just put that in a calculator. We know pi over 6 is sine of pi over 6 is 1/2. So you get what? 3 over 2. 4 is 8. So what do you get? Like 5 over 2. But you could figure that out algebraically. Let's go ahead and do 4. So let's go with a decimal for 5 over 2, 2.5. All right, let's go with pi over 4. Now you can put that all in the calculator as well. That's 4 minus 3 square root of 2 over 2. And you can just like take your calculator, turn it on. 4 minus 3 square root 2, close that off, divided by 2. And I'm getting like 1.9. This is about 1.9. So let me put these on my table here. When we had 2.5 for the radius, that happened at pi over 6. And then we had 1.9 at pi over 4. And let's go ahead and do pi over 3. Scroll up. R equals 4 minus 3 sine pi over 3. And we know that's going to be 3 times the square root of 3 over 2. So let's put that in the calculator. You can put the sign in the calculator. Because it was a special angle, I just put it in. Close off the parenthesis. Okay. And I'm getting that to be about 1.4. And then, did we do pi over 2? We already did pi over 2. Oh, you know what? We didn't do 0. We should do when sine is 0. Let's put this in. It's about, oh, that was at pi over 3. And let's go ahead and put in 0. What happens if we put in 0? You're just going to get 4. Okay, now let's graph these and see what happens. So 1 pi over 2. So I'm rotating pi over 2 and I'm counting out 1. All right, I'm going to rotate pi over 6, which is going to be to this first line here on my polar grid. And I'm going out 2, 1, 2 and a half. It's going to be about there. All right. And then pi over 4, well, that would be a little bit further, right? So it's going to be, pi over 4 is going to be like halfway in between those two lines. And I'm going out 1.4, so it's going to be somewhere in there. And let's see, what else do we have? This one. So pi over 3, I'm going to go to this line and count out, oh, it was 1.9. I thought that looked a little low. See if I can get that one out. Okay. My 2.5 went away. Okay, so let me go back to this one. There it is. And then my pi over 4 was 1.9, so really close to that. And then this one, pi over 3, 1.4, so a little bit lower there. Now, you could make the same points because we know from the picture it's going to be symmetric. So we could, about the theta equals pi over 2. So we could make those points on the other side. So 1, 2.5. Might make it easier when we go to draw it. Okay, not too bad. And then we have this point here, 0, so don't rotate, but go out. I'm sorry, 0 is the, did I do that backwards? I think I did. I think I wrote it down backwards. Where did I write it? If I plug in 0 for theta, I get 4. So let me fix that. It was 0 for theta, and I get 4. How come I didn't write that down? Okay, well, I can put it over here. R equals 4 minus 3 sine 0. This is all going to be 0, so you're going to get 4. I think that's why I didn't write it down. Okay, that's what I get for not writing it down. So I'm going to graph that 0, so don't rotate, stay on the polar axis, and go out 4. let's see, 1, 2, 3, 4. And then we can put one on the other side. 1, 2, 3, 4. And then we did pi over 2. We didn't do 3 pi over 2. So let's do that one. R equals 4 minus 3 sine 3 pi over 2. Now you might be saying, well, why would you just arbitrarily pick that? Well, I know at 3 pi over 2 I get -1. So I'm getting 4 minus 3 times -1. And so that's going to mean something to me, and that's going to be 7. So let's see, do I have 7 circles? 1. So I'm going 3 pi over 2. Let me scoot up a little bit. 3 pi over 2, so all the way over to here. And then 7 circles. So 1, 2, 3, 4, 5, 6. Oh, it's all the way out there to the end. Okay, so you could find more points. I'm not going to. I'm just going to try to sketch this in. So it's not a great drawing here. Looks more like the heart shape. Okay, I think I'm just making it worse. But that's how it graphs. So I am going to do one more by hand. You're probably like, where's that graphing utility? And the only reason we're doing that one, we're going to take like a little shortcut on the next video.